All right, can everybody hear me? Good, I can hear my echo, so that means you probably can. My name is Howard Durking. I am a program manager on the WCF team, and my focus is on REST and a new thing that we're developing called Web API. I was actually very excited to be coming to Atlanta because I was born and grew up in Houston, Texas, and I went to school in Alabama, and so being in Seattle now for 5 years, I was really expecting and excited about the sun, and of course, there's not any. So I'm afraid that we brought the Seattle with us, so I'm sorry for that. Very quickly, we're going to be talking about REST. We're going to spend a few minutes looking at some slides about why REST and what we're hoping to get out of REST, rather than just say, here is the dogma of REST and you will either conform or you will die. We're going to actually explore what are the benefits that we're looking to get from implementing REST. We're then really going to dig straight into code, and what we're going to do is systematically build up a RESTful service of a product catalog, and we'll go through some of the various characteristics of REST. We'll talk about them, and then we'll add them to our service. And then we're going to take a look. You remember I mentioned this Web API thing. So we're actually going to take a look at what that is, what it looks like, and how it improves on what's there today. So what is this thing that we're talking about? In a nutshell, REST is an architectural style that really patterns itself after the best of what the web has to offer. So if you care about things like scalability, if you care about things like managing a wide network of services at a reasonable or manageable cost, if you care about loose coupling between your clients and your services so that you can evolve both independently, then you should care about REST. So a couple benefits that we're hoping to extrapolate from REST, from this architectural style. The first is interoperability. Now, as an example, I came across a news article recently. And the thing I found most ironic about this article was that for an article talking about the destructive nature of Facebook, there is a share on Facebook icon just above the title. And because I care about my friends, naturally, I chose to share that. In addition, because not all of my friends are connected to me by Facebook, with another click, I could share the article on Twitter. And if you look at the bottom left corner of that dialog, you can actually see that I'm taking advantage of Twitter's URL shortening service to ultimately yield a tweet. Now, the common denominator that allowed me to do that was not the fact that all of these applications were running on the same SDK, they weren't running even on the same platform. The common denominator was that they all made use of HTTP as a full fidelity application protocol. Anybody here have a iPhone? Yeah? Anybody? Okay. Anybody have a smartphone in general? Yeah. So we see a lot of devices, right? And these devices are continuously adding to their ability to work with these remote services. But it's not just phones and tablets. You can see there's a set-top box, there's a GPS unit. I recently read a review of an oven that's being shipped that allows you to talk to it on your phone while commuting to preheat it. And while I think that that is an insanely dangerous thing to do, I can guarantee you that that oven is not going to have a SOAP-style application stack. The common denominator, again, is going to be HTTP. Anyone managed an application running on a server like the one on the left? I have. That's my server. And so we talk a lot about the cloud, right, and the move to the cloud, and what does that mean, right? You probably can't walk 50 feet at this conference without hearing somebody tell you something about the cloud. And while the cloud has a lot of benefits, what the cloud really enables is for you to build architectures that can really take advantage of what the cloud has to offer. As an example, if anyone follows the news, do you remember a story a few weeks back about a book publisher turned cloud service provider that had a slight service interruption. Yeah? Pretty familiar story. Now, the interesting part of that story was not that a service interruption happened. I mean, these are computers. For a service interruption not to happen would be amazing. What was interesting about that story is who was on that platform actually did not experience a service interruption. Did anyone read about Netflix in that case? Now, why didn't Netflix experience the same level of interruption that some of the other applications that were sitting on top of that platform experienced? And the reason is because they realized that what the cloud gives is not some silver bullet that I can throw my application over the fence, never to think about again, and it will always be 100% available and reliable, et cetera, et cetera. What they realized is that the cloud enables me to build an architecture, to build an architectural style that can be redundant and that can have failover, except I don't have to pay for all of that failover and all of that infrastructure cost up front. I can pay for it when I need it. So we're talking about REST. What are we comparing REST to? Have you guys written applications? Services look kind of like this, maybe a little more complicated. What are some characteristics about services, about this kind of service, in light of the benefits that we're hoping to achieve? Can somebody think of some challenges that may arise? Those of you who have done both SOAP and REST, anybody? That's right. What method is every request, every call going to go through? Post. Why is post problematic on the web? What is 98% of web traffic? Is it post? It's GET. So what do you think the web and all of its infrastructure is optimized around? It's GET, right? We're going to talk about taking advantage of HTTP semantics. And so what do I mean by that? I mean things like verbs, like methods, post, get, put, delete. We'll be talking about things like status codes. And you have some constraints in this model. Now, you certainly have some benefits, but in light of the challenges that we're hoping to overcome, this has some challenges with it. So we're talking about REST. Let's talk about some of the key characteristics. This idea of resources and representations. You see, I've offered myself up as an example resource. And the question really is, so what is a resource, right? It sounds a little existential, a little philosophical. Who am I, right? And the reality is that a resource is simply something that has an address. It has a way for you to get in contact with it. But you interact with resources via representations. And representations are of a certain content type or a media type. So if you were to call me on the phone, we would interact through voice. If you were to find me on Facebook, it would be HTML or it would be JSON or some one of those media types. Same goes for email. And one day in the future, my hope is that we can have a teleportation media type. Now, I will say that when that future arrives, I do hope that the networking protocol has a few more reliability guarantees than HTTP, as I would hate for my bits to get scrambled mid-flight. So let's look at the specific service that we're going to be building up. Again, simple product catalog, and I want to point out a few things. We're going to do a get for the collection of all products in the catalog. We're going to have a get method to return a specific product. We're going to enable you to post a new resource, a new representation to the collection. You can update or put a representation, and you can delete a specific resource. Now, a couple little precursors before we get into the demo. One is that for the client, because remember, the focus here is on building RESTful services, and we talk about great things like broad interoperability. And so to prove that, for the client, we're going to use Fiddler, and we're simply going to build HTTP requests. Additionally, you'll probably see that I am using some domain model code that I wrote prior to this demo. Again, the idea was to refactor everything that wasn't specific to HTTP and simply call that. So just want you to be aware of, just don't want you to think there's any magic happening. Aside from the WCF magic. So let's open our product service. And what you can see is I've just got this set up with a service contract, and because I'm hosting it in IIS, I have an attribute here to allow ASP.NET compatibility. I've also got my repository. Again, that's a part of my domain. And the repository simply represents my data store, which I have mocked up to be an in-memory collection. So the first thing that we want to do is let's create a get method so that we can pull down our list of products. And the way that we do that in WCF is to use an attribute called webGet. And the thing that we have to specify here is a property known as URI template. Now, for our collection resource, we want to access the collection at the base address of the service. And we'll see what that looks like in just a minute. But the idea is that we don't want to add anything to the URI. We just want to hit the base address of the service, and when we hit it with get, then that is going to route it to this method that we're going to create here. So let's create the method. And we're going to return a list of product DTOs, because I have a richer domain model that I don't want exposing to my clients. So I have a DTO that I've created. And let's call this get products. And we don't have any parameters. And all we're going to do here is go to our repository. We're going to call find all. And I've got an extension method here that basically turns my domain objects into my DTO objects. So let's return that. And I can run that. We're going to go over to Fiddler here. But before I do that, because I just realized, we talked about the base address, but how do we get to the base address? Are any of you familiar with MVC? Yeah? So one of the features that we have in .NET 4 is the ability to register a service route just like you would register an MVC route. So let's do that. We're going to call route table. And we're going to add the route. And what we'll add here is a service route. That's the WCF service route type. So service route. And here's where we're going to specify a route prefix. Now, what we want to do for our service here is we want to access it at my host/product. So let's go ahead and specify product. And then we want to provide a service host factory. And this is what's going to handle basically routing HTTP messages into our whole pipeline here. So we're going to say new web service host factory. And then the final thing we want to add is the type of our service. So this will be type of product service. So let's go ahead and run that. And then if we go over here to Fiddler, we should be able to author a GET request. To product. And we see that we get a 200 response code. And what we see there, and this is Fiddler, making the XML look nicer so that you don't have to look at it like this. What you can see is that we've actually gotten an XML representation of our collection of products. So let's go a little further, and let's be able to handle a GET request for a specific product. And what we want that request to look like is our host/product/the ID of the product. So we'll go back to our product service. And again, we're calling this with GET. And we want to specify a URI template, and we want to specify this a little different now because we want to be able to take in an ID straight off of the URL. So we're going to add ID in these curly brackets. That's the syntax to identify a parameter. And then now let's create the method. So we'll call this one getProduct. And it's going to take an ID which is of type string. Now, our repository needs the ID as an integer. So we're going to do something, we're going to just parse the string into an integer without checking whether it's valid. Don't ever do that in production, so you know. So we'll do find by ID, and we'll say int.parse ID. And then let's just return product. Whoops. Probably not var, huh? There we go. So when we run this, oh, we have build errors. Thank you. Forget my own extension method. All right. So when we run this one, we can now take a look at our request, and let's simply add 1 to it. And you see now we get back a single product. Now, when you search for something on the web or you type in a web URL, and that resource doesn't exist where you typed it, what happens? What response do you get in your web browser? 404. So because REST is really patterning itself after how the web works, it would stand to reason that if we can't find the product in our repository, we should return a 404. So let's do that real quick. So let's add a little gate here to say if product is null. And the way that in WCF you can throw out one of these error status codes or any one of these kind of status codes is by throwing a special type of exception called a web fault exception. So we're going to throw new web fault exception. And as a part of that, we can specify a specific HTTP status code. And so we're going to say not found. So let's go ahead and run this, and let's try to get a product that we know doesn't exist, just to prove the point. And we get a 404. Nothing terribly surprising there. So that's great. We can get resources, but what about operations that change the state of our resource? So let's take the example of we want to add a new representation to our collection. So in WCF, the attribute to note that you are about to author an operation that will change the state of your resource is with web invoke. So let's specify web invoke. And again, you have a URI template. And in this case, we want to post additions to our service's base address. And we're going to specify one additional thing, and that is the HTTP method that we want to recognize. So this attribute says, when a post request comes in to the service's base address, route it to this method. So here we're going to return a product DTO because we want to be helpful for our clients and actually return them the item that they added. And let's call this add product. And we're going to take a product DTO as our parameter. So from that, the first thing that we need to do in conformance with our domain model here is we're going to create an actual product domain object, and I've got an extension method here to basically take the product DTO and do that mapping. The next thing we want to do is actually store it to our repository. So let's go ahead and do that. And then we know that we also want to return it, right? So we want to return product.toDTO. Now, there's something missing here. In being a good HTTP citizen, there are two other things that we need to do when we are creating a new resource. Anybody know what those two things are? There's a status code, and there's a header. So we need to set a 201 status code, and we need to put the absolute URL to the new resource as the location header. And in WCF, we actually have a single method that will take care of both of those things. And it sits on the web operation context, and we care about the outgoing response. And it's this set status as created. Now, we need to create a URI, so let's call this new product URI. And you'll see that it doesn't exist, so we'll do a little bit of refactoring. So let's create this guy. And just if you're curious, I'm using ReSharper to do a lot of the refactoring stuff. I just didn't want you to think that, that there was some magic that your IDE didn't have that mine does. So what we're going to do here, and this gets a little bit messy, mainly because so many things sit under web operation context.current, incoming request, et cetera, and so it makes this look kind of long, but it's actually not too bad. We're going to construct a new URI, and we want to have some flexibility. So what we're going to do is we're going to use the base address of what the client passed to us to construct the first part, and then we're just going to supply the relative path to the new resource as the subsequent part. So we're going to do web operation context .current .incoming request .URI template match .base URI. See, that was easy, right? And then for the second bit, we're going to just put the relative path. So we have product / and then let's add the new ID of our product. Okay? So let's run that. We'll go over here to Fiddler, and let's actually take this response that we got from one of our earlier GET requests, and we're just going to effectively clone the representation here for our new representation. And we're going to go back over here to Request Builder, and we're going to create a new post request. We're going to route it to my collection resource. And let's paste the body down in here. And just so that we can be 100% certain that this is a new item, let's change the name. So we say new product. Now, one of the additional things that HTTP requires here is that we specify the content type as we're sending the request. And so the header for that is just content type. And it's application XML. So let's run that. And you can see we have a 201 response. And if you look down here in the headers, you can see the location to our new resource. Now, we can, in fact, execute this request as many times as we want. And each time, when you look down in the headers, you'll see that we have a URL to our updated item. So just for the sake of closing out our sort of standard service here, our standard RESTful service, there are a couple more operations. So let's just quickly, and I'll do this by way of snippet, let's add a put. So a lot of people have the question, when do I use post and when do I use put? And the simple answer is that you use post when you are creating a new resource, or when you're yielding a new URL, and you use put when you're modifying the state of an existing resource or an existing URL. So when we talk about put, we're talking about doing an update here. And so we take the ID of the resource that we're updating. So you can see that our URL is going to be, in fact, the same one that we used to get a single product, except we're going to change the HTTP method to put. We're going to look it up in the repository. You can see we've got our gate here to make sure that it's found. And then we're simply going to store it and return it. Additionally, the delete operation is really no different. We're going to accept the ID of the resource. We're going to look it up in the repository, make sure it's there, and then simply remove it. So I didn't feel like it was necessary to type all of that code because it's actually very similar to what we have already shown. So that gives us our basic service. Let's pop back over and talk about content negotiation. How many of you are familiar with content negotiation? A few folks. So here's the big idea in the form of a story. When I was 16, like 2 weeks ago, I wanted a car. And not just any car. I wanted a Corvette. Yeah. So I petitioned my dad over and over again. And my dad, who I will affectionately refer to as the server. And when I turned 16, I got a Corvette. Unfortunately, it was not quite the representation that I was hoping for. But I did get that resource. And that's the big idea with content negotiation, is that the client can supply the representation that it wants, and then the server can try to satisfy that format. And if it can't, then it can make some decisions, and there can be some back and forth depending on what content negotiation pattern you want to implement. There's actually a few different content negotiation patterns. There's what we're going to show today, which is server-driven, which is you tell me what you want, and I'll give you something. Maybe it'll be what you wanted, maybe it won't. But HTTP also provides us the headers and the facilities to do client-based negotiation, where you ask for something, I give you back what I have, and then you make the other request for what works best for you. So as you can see, what this looks like from an HTTP standpoint is the use of this accept header when I'm constructing requests. And that comes back on the response in the content type header. So let's actually take a look at this. This will actually be the shortest demo ever. And the reason is because in WCF4, it's a simple switch. And it's enabled out of the box if you use the REST templates that you can get off of Code Gallery. So let's go ahead and run this service again. And let's pop over to Fiddler. And let's take this GET request that we had earlier. Now you see when we execute it, we get XML that comes back for our product ETO. Now let's change that. So what we're going to do is specify accept application JSON. You see we got a 200 back. And if you take a look at the response, it's JSON. We didn't have to touch our service. We didn't even have to touch config, but I'm going to show you what the config looks like because it's very easy to sort of come to WCF thinking, oh yeah, you're doing all this, but what's hidden in that config file? Out of curiosity, did any of you guys go to Daniel Roth's talk yesterday on WCF simplicity? Great, so you probably know where this is going, and that is we've taken dramatic steps to simplify what's required of configuration in WCF. So just for the sake of full transparency here, let's actually look at what is in this config file. This is system.web stuff, just to hook up the URL routing. This is really the only thing. I'm going to just switch to, let's see, full screen here. This attribute right here is all that's required to enable automatic content negotiation between XML and JSON. The other thing that I want to point out is that content negotiation here is about the response. One of the cool things that I didn't show is that in WCF4, requests can automatically be, just out of the box, requests can be XML or JSON, and those can both be serialized into your actual DTO or your domain object. So if I were to mumble something really quiet, and you didn't hear what I said, if you like the person sitting next to you, your first response is probably going to be to lean over to them and ask, what did that guy just say? And that's the big idea here when we talk about intermediaries. You know, I was in a discussion earlier today with somebody saying, you know, you can still scale, you know, any normal kind of web service. And my response was, yeah, absolutely. But can you do it as cheaply? Cost is kind of a big deal. And what we get when we take advantage of HTTP as a first-class application protocol is that we get to leverage the entire infrastructure of the internet for free. If you think about when you issue a request from your web browser or from your service over the internet, think about how many hops that goes through. Right? It goes through your proxy if you're inside a firewall. Then it goes to your provider's proxy, and then so on and so forth. And your service provider's reverse proxy. And there are a whole bunch of nodes that sit in between you and that destination server. And so the big idea here is how can we take advantage of that for our services? Now, when we talk about caching, we're actually talking about two things. And I didn't know about the second one, so I'm going to hope that maybe you don't either and we can all learn something today. Caching, at its root, is pretty simple, right? You specify a time that this thing can live, and it sits in the cache until that expires, and then something happens. What I hadn't been aware of until not too long ago was what that thing that happens after the cache expires. And that's a process called revalidation. And you can take advantage of that revalidation process. So what happens is you get a resource, and you see in the response it has this thing called eTag. Now, eTag can be anything. It's an opaque string as far as your client is concerned. But it gets this back, and you can see it's also got some cache control settings. So what that's going to do, the cache control settings are going to specify that the representation should live in the cache for 60 seconds. And until that 60 seconds expires, subsequent requests will get a 304 not modified status code, which, because the browser adheres to HTTP, it knows that it can serve the content up from its local cache. But now when that 60 seconds expires, the browser can issue what's called a conditional get. And what that means is that the browser specifies, or your client specifies, an HTTP header called ifNoneMatch, and it supplies that eTag that it got on its first GET request. And what that tells the service, what that should tell your service is, I want you to get this resource representation if the eTag supplied does not match the eTag that is there. Right? Because that means that the state has been updated on the server. Now, if they do match, then my service can actually return a 304 and not have to actually send that representation back, thus conserving some bandwidth. Now, caching is really, really great, right? That's how we scale. But it also creates some problems, right? Most notably, if I've got 5 different clients that all have cached representations, and they're updating the state of those representations and sending them back, how can I maintain some consistency of my actual resource state? And we talked about e-tags a second ago in context of revalidation, but e-tags are just as useful for implementing some optimistic concurrency guarantees. So the workflow looks like this. User 1 is going to get a representation, or is going to put a representation using that e-tag value that we got from our previous slide, right? We have that e-tag value of 1. And you can see it was successful. But in the response, my service actually provided a new e-tag value, which indicates that the resource on the server has a new state. What that means is that when user 2 tries to update that state, he and the previous users actually do what's called a conditional put. We talked about a conditional get. A conditional put uses the header if match, which basically says, update the state of this resource if the e-tag I supply matches the e-tag that's there, right? Which means that the resource state hasn't changed, and you're OK to update it. Now, what you can see is that my resource state has changed. And so HTTP has a semantic in the form of a status code to notify the user that that state has changed. And that's that 412 status code. So what that means is that my user can now issue another GET request to get the latest state of that resource and run any logic necessary to make sure that his overwrites aren't causing conflict with the updated state. And then the second user can do another conditional put with the updated state, and assuming that the state hasn't changed again on the server, then that put will succeed. So let's actually see what that looks like. Let's go back over to our product service, and let's introduce some caching with our get method. So the first thing that we want to do is simply add those cache control settings. And we do that on the web operation context. And we do that through the headers collection. And let's add a HTTP response header. And let's use cache control. And then for the value, let's specify max age is equal to, we won't make you wait here for 60 seconds. Let's do 10 seconds. So what I can do now is I launch the browser. And let's go over to the network tools here and start capturing. And let's do product 1. Oops. So you see, our first response is at 200. Subsequent responses are coming back 304. And if we want to wait, for this thing to expire, then we'll get another 200. But let's actually show what that revalidation step looks like. So what we're going to do here is after we've validated that a product exists, we're going to do that conditional get. So again, that happens on the web operation context. And we're going to look at the incoming request. And there's actually a method here to check the headers and to throw that web vault exception if the validation fails. So we're going to do check conditional retrieve. And then we need to supply it that e-tag value. And so for this illustration, I'm actually using a property in my domain object called version. So we're going to specify that here. And then afterwards, we need to make sure that we actually supply the e-tag value so that it can be validated in the first place. So we're going to do web operation context, outgoing response, and we're going to call this method here called set e-tag. Now, why is there a method just to set a single header? According to the HTTP specification, the e-tag always has to be supplied in quotes. And that is a really easy thing to forget. So we went ahead and supplied the helper method to put the e-tag in quotes to just mitigate some of the risk of what in my case would be continual forgetfulness. So let's do this. Let's set a breakpoint so that we can see when this thing is actually getting hit, right? And let's actually call product 2. So you see first request, as you would expect, hits our breakpoint, and it looks like this one was already cached. So let's actually run that again. So now it's sitting in our local cache. And what's going to happen here is when we wait for those 10 seconds and we revalidate, so what you can see here is, let's look at our response headers. You can see this etag value of 0. And so when we issue that next request, you can see we hit this. We hit our conditional retrieve check. And then we actually get a 304 response. So we were able to send that not modified response even though we had to go back to the server. And then we've also reset our cache time to live. So that gives us the ability to do that sort of going back to revalidate, but at the same time giving us maximum scalability. Now, on the conditional put side of things, we have a very similar method. You may have seen it when I was working a second ago. But we see we have this update product method. So here we're getting our product. And what we want to do here is before we update it, we want to actually check to see if the state has changed. So again, we're going to look at the web operation context. And we're going to look at the incoming request. And we're going to do check conditional update. And let's provide that version number. And assuming that passes, let's actually, after we store it, let's send out a new etag value. So we're going to do that on the outgoing response. And let's set the etag, and let's set it back to the version. So when we run this and we pop back over to Fiddler, let's get a specific instance. And actually, we'll just show doing it in JSON. So let's execute this response. And you can see that we've got our representation. It's in JSON. So let's go ahead and copy that. And then let's do a put. And actually, before we do that, let's see what that etag value is. You can see that it's 0, because we're going to need to do a conditional put. So let's go over to our request builder. And let's change this to put. And then let's add our conditional header. So we're going to say if match, and let's put 0. Right? And so let's change the name here to mod, just so that we know that we've made a modification. And let's execute that. We've got a bad... Oh. So let's see, we've got product 1, we've got put here. Oh, it would probably help if the service was running. No, the service is running. Let's try this one more time here. So we've got application. Oh, that's right. That's right. Content type. Thank you. So content type is application JSON. What did I miss here? Right. So what we can see is we get this state back, and you can see the etag value here has changed. And just to make sure that we actually modified the state, you can see that we've modified it. Now, if we were to go back to our request builder and we were to execute this same request again, remember, it's got our old etag value. You can see that we have this 412, right? This precondition failed response code. So let's change it to mod 2, and let's just change our if match to our new etag value. And you can see that this time it succeeds, and it's changed our etag value, right? So this is how you implement some sort of concurrency, even in a distributed, cached kind of architecture. Now, hypermedia. How many of you have heard of hypermedia? All right. Yeah, this is sort of it's been a tenet of REST for a while, but people are just now kind of starting to talk about it. And the big idea is this. As we've been building up our service, we've been solving some problems, right? We have been increasing scalability by caching, and one of the other ways that we've done that is by increasing the scope or increasing the surface area of our URLs, right? We're not tunneling everything through a single SVC URL. We have all these different URLs for all of our different resources. And that's great, right? That solves a lot of problems, but it creates some new problems. And it's kind of a subtle problem that it creates, but the problem is that my clients now have to know how to construct those URLs. And so the problem is, what if you want to change your URLs? How can you do that without running the risk of breaking all of these clients now? Because, of course, your service has been hugely successful and you have, a bajillion clients that you don't even know who they are all connecting to it. And the answer is hypermedia. And the idea is very simply that you use links and you use media types that support linking semantics. And you send those to your clients, and your clients simply take those links and follow them. Now, this is equivalent to, how many of you use MSDN? I used to work on that team, so pretty familiar with, with that space. And how many of you get to content on MSDN because you know the address of every page on MSDN? All 68,000 of them. You get to that content, you get to those resources because you follow links. And it's the same idea. Remember, we're trying to model, in REST, we're trying to model computer-to-computer communications the same way that we understand browsing the web. And so the scenario looks like this. I use a media type, and I use the media type that contains links. Now, for this example, we're going to use Atom. If you're familiar with OData, this will look pretty familiar to you, right? They use the Atom protocol. And it has, you see link, that is a known semantic of the Atom protocol, the Atom format. So any client that can handle Atom inherently understands that link tag, right? It's not just structured data that you can parse. It has meaning. And additionally, you see that rel equals self. That's not just some random string that I chose. That, again, is a known identifier of link relationship. It's called a link relationship. And there's a set of industry standard link relationships that are registered with a service or a group called IANA. And I've provided the link when you take a look at the deck later so that you can actually go and see all of the different link relationships and media types that are available for you to use as you're building these types of services. But you can see I get this link back, and then really my client just needs to take that link and follow it. Doesn't matter what the link looks like. The client does not need to know how to put those links together. So let's see what that actually looks like. Now, the thing that I'm going to demonstrate here is a scenario that I know has been common for me over the years, and so I hope that it resonates with you. And the scenario is this. You build your service initially using integers for all of your objects or for all of your resources, probably because you're using SQL Server and identity columns are super easy and it just works, right? And that's great until your architecture gets a little bit more complex and maybe you have multiple SQL servers. And very quickly you run into this problem of, oh shoot, now I've got two SQL servers generating integer values for different rows, but it's the same value, and this thing is going to have some problems. So you want to, at that point, you decide to switch how you identify your objects to use GUIDs. Has anybody run into that scenario before? Has anybody experienced something like that? Yeah. And so when you're requiring your clients to know how to construct these URLs, that poses a problem, right? How are they going to know that they need to use this new GUID thing, and do you really want them to try and build a GUID? It's sketchy. And so what we're going to do is we're going to walk through that scenario, and we're going to use hypermedia as a way to make the client completely agnostic to what that URL needs to look like. Now for this, I'm going to expose a Atom URI path segment. In WCF4, we do automatic content negotiation for XML and JSON. And what's coming with the Web API bits that I'll show you enables you to do anything that you want, completely transparent to your service operation. We don't quite have that in 4, and so I'm going to add an additional template, or I'm sorry, an additional path segment. Let me get all of my namespaces resolved. And what we're going to do is we're going to use the syndication feed object model to create an Atom feed. And so we're going to our repository, and we're getting all of our products, and then we're going to create a new feed using some link here. And basically, we're just going to iterate through all of our products, and we're going to create feed items. Now, the thing to pay attention to is this section right here. Actually, more the first and the third. We're going to create our item URI, so we're letting the service determine what the URI is of the resource. And then we're going to create a link in our Atom feed with a rel of self so that the client can get to that specific product. Now, additionally, one of the things that we want to do is when we change this to GUIDs, we don't really want to touch that much of our existing service code. And so we're going to actually add a different service to process requests that are using GUIDs. So I'm going to include this service here, and I'll show you. It's basically the exact same thing as our previous get method. The only difference is that it's parsing a GUID instead of parsing an int. Right? So there's no magic happening here. And then let's go over here and let's actually register that register that service route in our global ASAX. So let's go route table, routes, add new service route. And we want to call this one product v2. And we'll use the same factory, so new web service host factory. And then let's specify our type. And there we go. So let's run this. And let's go over to Fiddler. And let's issue a standard GET request for our Atom endpoint. So here's our Atom endpoint. You see we get our 200 back. And what you can see here, if we look down in the Atom feed, is you can see our self link. So I could take that link and I could simply copy and paste it into a subsequent GET request, and it would just work. And you know it would just work because we've been using that same URI format the whole time. But let's actually change that URI so that we point all of our clients just immediately at our new service. So let's call this product v2, right, because that's the path that we've specified. And now let's actually use this ID GUID, right? So we run the service, And let's call that same request again. Comes back. Now, as you probably would expect, we now have that link pointed at our new service. So let's actually just copy that link, and let's try and run a request on it. Let's get rid of the tags around it. And you can see I get another 200 with my representation. You guys see how this is starting to work here? You see how I'm able to not break my clients? Yeah, nod. Yeah, okay. Now the other thing that Hypermedia really helps us with, and you saw it a little bit here, is this whole idea of service discovery. Now for those of you that have written a lot of WCF services, has service discovery been problematic in the past? Yeah? So just like we've decoupled our clients from knowing how to construct the URLs to get representations, or to deal with representation formats, or resource formats, we can use Hypermedia and we can use those link relationships to actually bring on or advertise new types of services. So for example, and they don't even have to be services that we own. So let's say that in our Atom feed, we want to actually connect up with a whole different application. All right, so we've got orders, and we want to allow people to buy them. So what I can do here is I can construct a URI for my product, or for this buy service, and I can then just add it as a link in my Atom feed. Payment, just like self, is a known link relation in the IANA registry. So when we run this, and we go back over to Fiddler, and let's issue that request one more time here. Oh, not that request. This request. And we look down at the feed, you can see that we now have this link here. Now, you may be looking at this and going, wait a second, are you going to actually buy something through a GET request? That's horrible. And you're right, that's horrible. Don't ever do that. The way that these kinds of workflows work in Hypermedia is that when you follow a link, you always follow on GET. And then there are patterns for returning, let's say, a content type of a form, right? Xforms is one of the media types that supports this kind of pattern. Or, a lot of people have actually started using XHTML forms, not as a rendering media type, but as a semantically understood media type, right? Because you can use forms. And as a part of getting that back, you can then, as the client, populate it, and then that form specifies the URI to post to, as well as the method to use, whether it's post, put, etc. So that's the pattern for interoperating when you're actually adding state, as well as just getting things. Okay, so showed you where we are today with WCF 4 and REST. Let's talk a little bit about where we're going. Have any of you used or at least downloaded the Web API bits on Codeplex? A couple folks? That's good. So there's a couple big themes here in terms of where we're going with our Web API bits. You saw we were able to do a lot of the things with respect to building RESTful services on 4, but some of them looked a little bit kind of annoying to write, right? Every time I have to write, web operation context dot current dot incoming request dot headers dot blah 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 blah, a little bit of me dies inside every time I have to type that. And so one of the things that we've tried to do and successfully done with our Web API bits is created a much simpler model for creating these services and for dealing with the web context directly. And the way that that works is you can actually request the HTTP objects as input parameters to your service and pass them as output parameters. In fact, we have generic types where you can say, the HTTP type with or of product DTO. And then you can actually work with both your typed objects and the HTTP message. Now, what are those objects? Have any of you used the REST Starter Kit? Did you like the HTTP client bits? Did you use that a lot? It's been a while. Okay. So one of the key features of the REST Starter Kit that people said they really, really liked was an object model for dealing with the HTTP request message and HTTP response message. And not only are we bringing that forward with Web API, but we're actually making it symmetric. It's going to exist on both the client and the server. So you'll have a much cleaner sort of end-to-end experience programming on that model. I also talked a little bit about the pipeline, so I'll delve into that a little bit more. WCF has a few extensibility points, yeah? And a lot of times it becomes a bit of a challenge, especially when you're new to WCF, to really understand which one you should plug in where and why and how to even make it work. I remember my first entree into WCF was I wanted to wire up a inversion of control container. Are you guys familiar with that? Is that basically it's a piece of code that you can specify a class name and you can say how to create the class, and then you let it create the class and resolve any dependencies and create other objects and so on and so forth. And I wanted to wire that up in WCF. And it took me 4 different classes to plug together in various ways so that I could actually have my container create my service rather than the typical flow. So one of the things that we've done with Web API is we've streamlined the extensibility points to basically 3 primary touch points. You can plug in at the message level and deal specifically with the HTTP request and response. You can plug in at the operation level and deal with the actual objects, right, as things have been serialized and deserialized. And you can plug in formatters. And formatters is how we enable that automatic content negotiation for anything. So let's take a look at what I mean by anything. Now, if you download the bits off of Codeplex, you will see there's a bunch of samples. And the sample that we're going to look at is something called the Contact Manager. So let's open our samples solution here. And what we're going to do is just run it first, right? Because let's just take a look at what's going on there. So you can see we have this, super pretty DHTML application. One thing to point out here is that this is actually just a static HTML page communicating all browser to service. And if we go back over here to Fiddler, you can see that, oops, if I get the port right, and I did, you can see that we have this default XML, and I could do the same thing with JSON, but I doubt that would impress you too much because you've already seen that working on the 4.0 bits. But let's say that I wanted Glenn's picture. So I can specify, just like I did with my JSON and with my XML. And look, I get a picture. Same URI, same verb, different accept header. What about something else, right? I mean, this image, that's pretty cool. What about a text format, but one that is not really XML or JSON? right? So let's go text.directory. Now, does anybody know what this is? Text.directory, you know what that represents? Have any of you worked with vCards before? Yeah? In pretty much every contact management app known to man. So let's specify that as our accept. You can see we now get a vCard. Now, how does this work? How does this crazy magic work? What you can see if you go look into this project is that we have a bunch of formatters here. And so let's take a look at this vCard formatter. And there's a couple things to point out here. The first is that the formatter itself declares what media types it can respond to. Additionally, there's some overrides to basically take the object and write it to the stream. And that's it. You can write as many of these as you want. They can be tested without needing you to spin up a service host, right? They're all unit testable. And they can be reused across different applications. Additionally, the thing I would want to point out here is we didn't have to go crazy with the config file to make that happen. One of the things that we've done with our Web API bits is we're doing a lot of work around code-based configuration. We saw a lot of people that were doing MVC applications that really took to that. And a lot of people really don't like the whole coding with angle brackets. And so if we look, we can see that we have an operation handler factory, which we just wire up in our global ASAX, that is simply registering all of these providers, or all of these formatters. And again, each formatter says what they can handle. So, quick recap. The benefits of REST, why it should matter. If you care about interoperating, whether it's with a variety of different applications, whether it is with a variety of different devices. If you care about scale, and if you care about scaling while not breaking your pocketbook, then REST is something you should take a look at. With WCF, a couple of the key concepts we looked at, resources and representations, and what that means, how that looks. Content negotiation. In 4, you have automatic content negotiation for XML and JSON. With the Web API bits, you're limited only by your imagination. Intermediaries. So how we control caching, how we control revalidation, and then how we deal with managing updates to potentially stale resources. And then finally, taking a look at hypermedia. And I hope that what we've shown with hypermedia has been something that resonates as solving a real problem. As you get further into hypermedia, you'll discover that you can actually do a whole lot more with it. You'll hear an acronym used, it's a terrible acronym, but it's hypermedia as the state of the application engine. And it looks like hate OS, which is why we don't use it. Because we don't want you to hate anybody. And so you can do a whole lot more than simply, changing your URL scheme, right? But this is a good example of the big idea here and why you should start taking a look at it. To learn more, I'm sure the deck will be made available later, and I've put a bunch of links here. The first one, of course, that we really want you to go check out is to download our CodePlex bits. Take a look at it, see what you think, give us feedback. And then Roy Fielding's thesis, this is really the sort of doctrine of REST, right? This is where it's all laid out. As you would expect from a PhD thesis, it's not the most entertaining reading, but it's valuable reading as you go further and further down this RESTful path. The IANA registry, both for media types and for link relationships. If you want a great book to just go sort of front to back, this book has helped me out quite a bit. It's called REST in Practice. I think it's O'Reilly. But it's a fantastic book. It covers all of these concepts in a great deal more depth. And then the MSDN WCF Developer Center. And then some info about how to contact me. I'm very proud that I have the coolest alias at Microsoft. So it's just my first name. Shouldn't be hard to forget. So feel free to shoot me an email if you want to follow up. If you want to be experimenting with some of these bits, and you want us to help sort of get involved and take a look at your specific scenarios, we'd love to talk to you. Some related content, some related sessions. Some of it's already happened. Some of it hasn't. So just a few notes about things you might want to check out. And then, of course, all of the great TechEd resources. And evaluations. I will preach at you, as I'm sure your other presenters have. Fill out your evaluations. We want your feedback. If there are any questions, I'd be happy to take those. Otherwise, thank you for attending.